Hi everyone, my name is Dr. Hang Ding and I'm teaching programming with Go from IU South Bend. And this lecture is the second part of the topic 1.2 of flow control statements. And in this lecture, we will learn about the if-else, switch, and defer statements. The if statement in Go works very straightforwardly. It starts with the if keyword, then followed by a conditional expression or Boolean expression, and then followed by the body of the if statement. The if statement in Go is like is a for loop. That is, you don't need to surround the Boolean expression with parentheses, but the braces are required even if you have only one statement in the body of the if statement. So, for example, here the condition or the Boolean expression is x less than 0. So if x is less than 0, then we will return the square root of minus x plus I. So that is the body of the if statement. And after the if statement, you should also print out like the square root of x. And so that is in the function sqrt. And in the function main, you can call the function sqrt. So this is just the entire program that has an if statement. This is very simple if statement. You can have more statements between the braces in the if statement. You don't need to have just one. Like the for statement, the if statement in Go can start with a short statement to execute before the condition. And note that variables declared by that short statement are only in scope until the end of the if statement. For example, here we define an if statement with the condition v less than lim. And but before this condition, we also have a short statement that declares and assigns variable v to be the power of x to the n. So here we use math.pow to calculate the power of x to the n. Pow is a function inside the math package. Okay, so the variable v declared in this if statement has the scope within this if statement only. So if you if you access v before the if statement or after the if statement, you will get an error. And also when you have the short statement in the if statement before the condition, you need to separate it with the semicolon. So the semicolon should go after the short statement, so that you can separate that short statement with or from the condition. You can also write an if statement with an else block. The else block starts with the else keyword that must be in the same line as the closing brace of the if statement. The else is followed by statements within a pair of open brace and a closed brace. Like in the if and the for statements, the braces are required in the else block. Also note that variables declared inside a short statement in the if statement are also available inside any of the else blocks associating with the if statement. For example, in addition to the if statement with the condition v less than lim from the previous example, here we add an else block to execute when v is larger than or equal to lim, which is opposite to the condition of the if statement. Variable v is declared in the short statement in the if statement, so it's also available in this else block, and we can print it when v is larger than or equal to lim. You can also have 0 or more else if statement between an if statement and its associating else block. Here is the syntax of an if statement with an else if statement and the else block. Each else if statement must start with the else if keyword right after the closing brace, and in the same line as that closing brace of the previous block. Then is followed by a condition, and then the statements in a pair of braces. Again, these braces following the condition of each else if statement are required. Also, you can write a short statement before the condition of an else if. And in this case, the code or statement within the braces after the condition of this else if statement will be executed when the condition of the if statement is false, and the condition of this else if statement is true, right? And then the else block code is executed when both condition 1 and condition 2 are false. Here is an example of a Go program with the if, else, and else statement. This program tries to print out the current operating system that is running on. It declares variable OS in the if statement and assigns OS to the constant Go OS from the runtime package. In the if condition, it checks if OS equals the string Darwin. Okay? And if so, then it will print out OSX. In the else if condition, it checks if OS is equal to the string Linux, and in that case, then it will print out Linux. And in the other cases, then it simply print out the variable OS. A sequence of if, else if, and else statements, like those in the previous example, can be rewritten in a shorter way using a switch statement. Go switch is like the one in C, C++, and Java, JavaScript, and PHP, except that Go only runs the selected case, not all the cases that follow. In effect, the break statement that is needed at the end of each case in those languages is provided automatically in Go. Switch cases evaluate cases from top to bottom, stopping when a case succeeded. So it only runs the first case whose value equal to the condition expression. And as in the if and for statements, The switch statement can have a short statement to be executed before the condition expression, and any variable declared in that short statement is available within the switch statement only. But the condition expression in a switch statement doesn't need to be a Boolean expression as in the if and the for statements. This example of a switch statement is equivalent to the sequence of if, else if, and else statements in the previous slide. The condition expression in this switch statement is variable OS, which is declared in the short statement of this switch statement. And the default case is equivalent to the else case in the if-else statement sequence. Another important difference between Go's switch and C, C++, and Java's switch is that Go switch cases need not be constants, and the value involved need not be integers. For example, in this program, we write a switch statement to check when the next Saturday is. The condition expression of this switch statement is the constant Saturday of time weekday defined in the time package. So time.Saturday is of time.weekday. Before the switch statement, we declare variable today and assign it to the current weekday. So variable today is also of time.weekday. The cases in this switch statement are not constants, but the addition of today and a number. The values of these additions are of time.weekdays. In fact, time.weekday is also an alias of integer, but it's treated as a different time. So you can still add like an integer to a weekday value, but this integer is understood as weekday. So the value here is of time.weekday instead of an integer. In Golang, you can also have a switch statement without any condition, as in this example. And a switch condition without a condition is the same as switch true. That means that it's the same as writing a switch with the condition being true. And this construct can be a clean way to write a long if-else change. Okay, so here this is the same as writing if t.hours is less than 12, then we print this morning's. Else if t.hours is less than 17, then print out good afternoon, and else print good evening. Now let's discuss the default statement, which is a novel mechanism in Go to make things simpler. A default statement defers the execution of a function until the surrounding function returns, even with panicking. The surrounding function is the function containing the default statement. For example, the surrounding function of the default statement in this example is the main function, because this default statement is in the main function. So the call to function println in this default statement is deferred until the main function returns. Syntactically, a defer statement is an ordinary function or method call prefixed by the keyword defer. The arguments of the deferred call are evaluated immediately when the defer statement is executed, but the actual call is deferred until the function containing the defer statement has finished, whether normally or by panicking. So in this example, the deferred call is the call to the function print ln, which has arguments words plus exclamation point. The argument is evaluated right away to get the string word exclamation point, but the printout of that string is deferred until the main function has finished, at which point the string hello has been printed out. So the result of this program is the printing out of the string hello before the printing of the string word exclamation point. Note that any number of function calls may be deferred, and they are executed in the reverse of the order in which they were deferred. Because deferred function calls are pushed onto a stack, and when a function returns, its deferred calls are executed in last in, first out order. For example, in this main function, there is a for loop with the control variable I going from 1 to 6. And for each value of variable I, it executes a defer statement with the call to function print to print out the value of I followed by a space. So there are 6 deferred calls to function print in this main function, where the print of 1 is deferred first and the print of 6 is deferred last. Before the loop is executed, the main function has printed out the string counting. During the for loop, the call to print of 1 is deferred first and is pushed to the stack first but not executed yet. Then the call to print of 2 is deferred and is pushed to the stack after the first deferred call. And then the third to the 6th deferred calls are pushed to a stack but not executed until the main function finished. After the for loop, the main function also prints out the string done and then finishes. After the main function finishes, then the calls to function print in stack are popped out of the stack and executed in the reverse order. So the print with the argument 6 is executed first and the print with argument 1 is executed last. As a result, we see that it prints 6, 5, 4, 3, 2, 1. If there were no defer keyword here, it could have printed out counting, then 1, 2, 3, 4, 5, 6, and then done. Defer statement is commonly used to simplify functions that perform various cleanup actions, such as closing files. For example, let's look at a function that opens 2 files and copies the content of one file to another. First, it opens the source file for reading, then checks if the opening has an error, and if so, it will return. Otherwise, it proceed to open the destination file for writing using the call to function create in the OS package. And so then it also check if the call to the function create is successful or not, and if not, then it will return. Otherwise, it will make the copy from the source file to the destination file, and then afterward it close both the source file and the destination file and then return. So this works, but there is a bug. That is, if the call to os.create fails, then the function will return without closing the source file. And this can be easily remedied by putting a call to the src.close before the second return statement. But if the function were more complex, the problem may not be so easily noticed and resolved. By introducing default statements, we can ensure that the files are always closed. Here is how we rewrite the function copy file using default statements. Default statements allow us to think about closing each file right after opening it, guaranteeing that regardless of the number of return statements in the function, the files will be closed. In addition to closing files, a default statement is often used with other paired operations like connect and disconnect, lock and unlock to ensure that resources are released in all cases, no matter how complex the control flow. The right place for a default statement that releases a resource is immediately after the resource has been successfully acquired. For example, the default close call is placed immediately after the file has been opened successfully. So this is the last slide of this lecture. Thank you for watching, and we'll see you again in the next one.